Welcome to 9.3, Part 1, Absolute Value Equations and Inequalities. Now, there's a couple properties of the absolute value. One is if we have the absolute value of the product of something, we can take the absolute value of the individual pieces. If we have the absolute value of a quotient or a fraction, we can take the absolute value of the numerator of the absolute value of the denominator. And then finally, absolute value of a negative quantity is the same as the absolute value of a positive quantity. Now, I want to consider the following things. This right here. Now, when we're trying to solve this right here, we're trying to find all the numbers that we can substitute in for x to make this a true statement. So there's an obvious solution, x equals 4, because if we have the absolute value of 4, that definitely equals 4. But one that's not as obvious is negative 4, because if we plug negative 4 in for x, the absolute value of negative 4 is 4 as well. So there's two solutions, a positive and negative solution to that right there. Now if we consider this right here, we're still trying to find all the values we can plug in for x to make this a true statement. The problem is that this right here, the absolute value always gives you positive things. It can never be negative, so the answer to that is the empty set. That is, there are no solutions. We can't plug anything in. If we plug a positive number in here, it stays positive, so it can't be negative. If we put a negative number in here, the absolute value makes it positive, so it'll never be negative. So a couple things to keep in mind here. Now, same thing for these next ones. Like this one right here, if we're looking at this right here, we want to think about some numbers we can plug in to this. And we can plug 4 in. That gives us a true statement. So 4, that's good. And we can plug 5 in, and 6 in, and 7 in. So if we think about this, definitely 4 and everything above 4 is a solution, because if we plug it into that absolute value right there, it'll give us a true statement. Absolute value of 5, definitely greater than 4. Absolute value of 7, definitely greater than 4. But there's also some solutions that are down here. That is negative 4. If we plug negative 4 in, absolute value of negative 4 equals 4, which is greater than or equal to 4, so that works. Also negative 5. Absolute value of negative 5. Is that bigger than 4? Yeah, because that's 5. So it's not just the pieces over here, but it's the pieces over here. And if you think about that, this right here, it looks exactly like an OR problem from 9.2, and that's exactly how it works out. This works out to be two things. It's either this piece, which is x is greater than or equal to 4, or, now, x is greater than or equal to 4 is part of the solution. It's like if we drop the absolute value after that. This piece right here is x is less than or equal to negative 4. So just like with this equation up here, there's a positive case, that's this right here, and there's a negative case, that's this piece right here. And notice, the positive case, we write the absolute value inequality just as it would look if we drop the absolute value bar. The negative case, we make the 4 negative and we flip the sign. And that's inherent, and we're really dividing by a negative, and that's why we flip the sign right there. So with these types of ones where we have the absolute value is greater than a number, it's always an OR problem, and there's a positive negative case. Now if we consider this inequality over here, the absolute value of x is less than or equal to 4. If we think about some numbers we can put in here, we could put 4 in, once again. We could put 3 in, 3, 2, 1, 0. But we can also put negative 2 in, negative 3, negative 4. We can go all the way to negative 4, but once we have negative 5, the absolute value of negative 5 is not less than 4, because that would be 5 is less than 4. That doesn't make sense. So notice, when we have absolute value is less than the number, we have this little interval in here, which actually turns out to be an AND problem. So over here, if we have absolute value is greater than number, it's an OR. If we have absolute value is less than a number, it's an AND. So this turns into an AND, and it works in the same way. There's a positive case, that is where we have x is less than or equal to 4, and there's the negative case. Well, the negative case is going to be x is, flip the sign, greater than or equal to negative 4. So positive case, just write it like it would be. Negative case, flip the sign. And this is true for both this type of absolute value inequality and this type of absolute value inequality. The thing to remember is when we have absolute values greater than number, it's an OR. Absolute value is less than a number, it's an AND. Okay. So that's kind of the ins and outs of these absolute value. We're just going to do some problems now. And the thing you want to keep in mind is we always want to isolate the absolute value before we start considering the positive and negative cases here. And that's pretty much it. So on this first one right here, we have 4x minus 9, or the absolute value of 4x minus 9 equals 14. So this is going to be true if this thing in here equals 14. That is 4x minus 9 equals 14. Or it's going to be true if the inside equals negative 14, because in the absolute value it gives us positive. So we also have to solve 4x minus 9 equals negative 14. So two different cases, the positive case and the negative case. So we solve these independently. Add 9. So we get 4x equals 23. Divide by 4. And we get x equals 23/4. So this is one of our solutions. And we can always check by plugging it back into the original equation and seeing that. Now, the second one right here, add 9 to both sides. Again, this is the negative case. We still get 4x equals, 9's cancel, negative 5, divide by 4. We get x equals negative 5/4. So those are our two solutions to that problem right there. That is how it works. Now the second one we have right here, let me draw a line. The second one we have right here, we need to isolate the absolute value before we do our positive and negative case. So subtracting 7 from both sides gives us the absolute value of x equals 11. Now this kind of goes back to the original one. This is going to be true if x equals 11, because if we plug 11 in there, right in there, the absolute value of 11 is 11. So that's the positive case. Or we have the negative case, x equals negative 11, because the absolute value of negative 11 is also 11. These are really OR problems, but there are two solutions, and those are the two solutions. Okay. So this last one, kind of a similar situation going on. We have absolute value of an equation equals absolute value of an equation. There's still two cases. There's a positive case where we leave both sides positive, and then there's a negative case where we make one of the sides negative. So let's do the positive case, and then we'll do the negative case. So we get 2a plus 4 equals 3a minus 1, or we have 2a plus 4 equals negative 3a minus 1. So once again, just like we had a positive 11, negative 11, and up here we had our positive 14 and our negative 14. Down here we have both a positive and negative case. So now we're charged with solving these equations. So I'm going to move the a's to the left here, so subtracting 2a's. So if I'm moving the a's to the right, I'm going to move the numbers to the left, so add 1. Those cancel, we get 5. 3a minus a is a. 1's cancel. So we get a equals 5. Okay? So that's one of the solutions. So we can always plug that back in and just do that really quickly. 2 times 5 plus 4. The absolute value of that should equal 3 times 5 minus 1. 2 times 5 is 10, plus 4 is 14. The absolute value of 14. 3 times 5 is 15, minus 1 is 14. Absolute value of 14 equals absolute value of 14. Yep. So we can always check these. Now this one here, we need to distribute our negative into here and here. So we have 2a plus 4 equals negative 3a plus 1. I'm going to move my a's to the right now. Add 3a. Subtract 4. So 2a and 3a is 5a. Our 4's cancel. Our a's cancel. And minus 3. Divide by 5. And we get a equals negative 3/5. So that's our second solution. We could plug that in. It will work the same way as the one before. But there's the two solutions. So just remember with absolute value equations and inequalities, there's two cases, a positive case and a negative case. And we'll see you for the inequalities in the next part.